someone from the class, maybe CR, can confirm on that this activity will be plagiarism activity will be minimum. I know it cannot be avoided, but it has to be.
Sir, for the plagiarism thing, like when we submit our zip file, it contains the screenshot, and in the screenshot, it is the name for Ubuntu. Like my name is written there in place of Ubuntu. Like so, the name is already there in the screenshot part.
Agreed.
So
Agreed. But see, you can always take somebody else's code and run it on your screen and then submit it. Right?
So that is, I completely understand your part. But the third thing is, like, if we get less time, no, then if like I don't understand Ubuntu much because it's new for me. So it takes time for me to go with things. So like if the time would be less, then I would not have enough time to like understand the things on my own and do it from on my own. Because if I get time, then at least I would have the motivation to do it and like do it slowly and then submit it. But if the time would be less, then I would be like have no options other than just to submit it.
But what if I provide you the lab assignments on Friday?
So the issue with that is like you have provided the quiz like the Moodle today, but the thing is like when I have read the questions, but there are some of the parts I'm not clear with it.
Okay.
So then I would ask the TAs over there, and in the lab, so it is a bit difficult when like you are in the meet and doing the lab simultaneously. It becomes very slow process for us. So like even at least I'm not asking like the submission should be on Sunday like you did provided us for the last lab. At least a day or two would be like beneficial because we could clear our doubts with the TA and then we could do the things on our own after the lab ends.
Okay, fine. So let me discuss it with TAs and then we will try to do the best we can, right? So I take your point that you want to, so basically I take your point saying that you want to discuss your doubts with TAs and that once you discuss the doubts with the TAs, you need extra time to then work upon your problems based on that discussion. So that will require extra time for submission, right? That is what you're saying.
Yes, sir. Tuesday is a big hectic day for us because we have like pegged up schedule from the whole day. So like after the lab, we are a bit tired. So
Vivek, you are the CR or Nikhil, you are the CR?
No, sir. We don't
No, sir.
have.
Acha, you don't have CRs in your batch?
I think no, sir.
No,
okay.
Sir.
All right. Okay. So let me talk to TAs and then we'll go with So I'll try to give you a day extra based on your request. But just my request to you all is that why do we have the lab assignments is so that you can practice on your own, right? So I request all the students to make sure that you practice on your own, even if you don't know the answer of all the questions. I mean, I'm sure that if I give you like 5 questions, out of which you will know 2 or 3 at least, right? So solve those on your own. I don't mind group discussions, right? I don't mind group discussions. I don't mind you guys talk to each other and work on the problem together. That is fine. But simply taking somebody else's code, right, without even understanding what it is doing and then submitting is a problem, right? So then you won't even understand what actually the problem was and what you're supposed to do, right? So that is my humble request to everyone. All right?
Yes, sir.
Okay. All right. So let me start with the lecture. Let me share the screen. All right. So I think we finished this particular slide. I hope you are able to see my screen.
Yes, sir.
Yes,
Okay.
sir.
All right. Thank you. So basically, this is the slide that we covered in the previous lecture. So we'll continue with the pointers arithmetic thing, but with now arrays, right? So this sort of thing you may have also studied in your C programming course, but I want to again do the revision a little bit. So let's say you have the array declared in this manner, and then you have the pointer declared in this manner for the integer data type, and you are assigning the pointer value to be the address of the first element of an array. Right, so A0 basically gives me the first. Now, if I like what is the value that will be printed, or is this even a valid way of doing the pointer arithmetic? So anyone can answer, like what is this going?
Fifth element of array. The value of the
From the array.
yes.
Sir, the sixth element actually.
Sorry, which one?
Sixth element.
Sixth element. Right. So basically we are saying that the first element is just pointed by the PTR pointer, right? So the first element always going to be just pointed by the PTR, and then we are doing +5, right? So when we say +5, we are not actually adding 5 bytes to the 5 bytes to the pointer address value. We are actually adding 5 integers, right? So always when you do the pointer arithmetic, it is going to look at the data type of the pointer, and whatever offset that you add to the pointer will be offset multiplied by that size of the data type, right? So basically the arithmetic would be something like this, that PTR plus 5 will then become PTR plus 5 times the size of data type. So in this case, let's say PTR is pointing to integer, so we are going to say size of integer, and so this is going to be PTR plus 20, and let's assume that PTR or the starting address.
So, are you recording the lecture?
Did I miss it? 1 second.
Yeah.
Okay, let me start. 1 second. Recording meeting. Thank you for pointing out. Since we were doing the lab discussions, I think I forgot to start the recording. Okay. All right. So now it's started. So when we do this arithmetic, right? Basically, what we are saying is PTR is the pointer variable pointing to the type of value which is integer. So when I say 5, basically it means that 5 multiplied by the size of this data type. Okay, that is what this 5 is going to be representing, right? And so therefore what will happen is that you do 5 times the size of integer, which will give me 20. Now let's assume that my array, right? So so let's say the address in memory, right? So my memory address is let's say 100 is going to be storing A of 0, right? Now because A is also an integer value, right? A of 0 is an integer value. The array is storing an integer value. Each of this will be 4 byte information, right? So A 100 to 103 is going to be the A of 0, right? Then 104 to 107 is going to be A of 1, and so on, right? So this is basically what we are doing. So what will happen is eventually when you do it like this, you so 8 to 11, then 12 to 15, and then 16 to 19, to 23, and so on, right? So this is how the array values are stored. So 1, index 2, index 3, index 4, and index 5. This is how the values are stored in the memory for each of the array elements, right? So basically when we do this, basically what it is doing, it is saying size of integer multiplied by 5, which gives me 20. And when you did PTR equal to address of A of 0, basically what happened was PTR was assigned a value of 100, right? Because A of 0 is the element and the starting address of A of 0 is the value 100. And therefore that 100 was assigned to this PTR, right? So this value of 100 was assigned to the PTR because that is the starting address of an array, right? And so when you do this arithmetic, you get the value 120. Okay? And when you look at 120, which is basically this element, okay? And what is this element? It is the sixth element of an array. This is how the pointer arithmetic works for the array is concerned, right? You can also use this particular format. So instead of using A of 7, you can also do PTR of 7 once you assign the PTR with this address. Also, doing address of A of 0 and just doing PTR equal to A means the same thing. Why it is the same thing? Because normally primitive data types in C are referenced by value. Okay, so if you have an integer variable, for example, that when you say print I, you actually print the value of I, whatever the value is stored in that I variable. But since A is not a primitive data type variable, it is an array. So arrays are always referenced by the address, right? Arrays are always referenced by its address. So the starting address of A is what this A is going to be representing by, right? So we say A, that means it is again the starting address of an array, which is 100. So whether you use this particular format for assignment or you use this particular format of assignment, they both mean exactly the same thing. Okay, they both mean exactly the same thing. Okay, I've started it. So now let's look at these two. Does anyone know what is the difference between these two and what values will be printed in this case and in this case? Anyone?
In the first one, the address would be increased, and in the second, the value it is pointing at, that would be printed.
So we know that PTR is pointing to the first element of an array. So in this case, what will be printed?
Value of first element.
Value of first element. Why would that be?
A value of first element plus 1.
Value of first element plus 1.
Sir, in the first one, the value of the first element will be printed, and the next one, it will be preceded and then it will be printed.
So what will be printed here? Value of which element will be printed, or value of which address will be printed?
Second.
Second.
A of 1.
So,
yes.
so
Yeah.
as simple as that. See, basically what you have to worry about here is the precedence of the operator, right? So you have to look at whether the star operator has a higher precedence or the post increment operator has a higher precedence. That is what we are concerned with here. Okay. Now we know that the star operator in this case has a higher precedence. So what will happen is first it will execute only this part. And what does this mean? It means wherever the PTR is pointing to, give me the data value from that pointer. And PTR by default is pointing to the first element. So basically, when I do star PTR, it is same as A of 0, which is the first element of an array. Then I am applying this post increment operator. What does it mean? It means that whatever A0 contains, that value must be incremented by 1. So assuming that, let's say the first value here is 5 and second value here is 10, let's say, right? Third value here is 15 and so on. If this is how the values are stored in the array, right? In this printf, it is going to print 6 because it is going to first access the first element of an array by using star ptr, and then we are saying increment that value by 1 and then print it, right? So it's going to take this value 5 and then plus 1, 6, and then print value 6. If you do this, now what you have done is you have changed the precedence of the operators by adding this parenthesis. Okay, so you said that I want to increment the pointer value first. Okay, I want to increment the pointer value first before accessing the data. So when you do that, basically now your PTR is going to point to the second element at index 1. So this is equivalent to A of 1. And then you say star, right? Which means whatever is the value pointed by this pointer, give me that value. And that value is the value of A of 1. So for this printf, it is going to be printing the value of 10. Okay, so again, whenever you use pointer arithmetic in your code, you must be worried about the precedence of the operator, especially in the pointer arithmetic, because you can see that by just not including the parenthesis, how big of a change it can make, right? So that is what you need to worry about. All right, now we move on to the structure and pointer. We are using pointer with the structures. So we know that, yes.
Sir, in the previous slide, so in the first case, it is printing only A of 0. I checked it out in compiler.
Yes, sir.
You checked it out in compiler. Yeah.
Yes,
So
it is only printing
It is
A of
post
0.
operator, that's all.
Post increment. Post
Yeah,
increment.
then
So basically
PTR will be
printing first and then
incremented.
incrementing it. So basically what would happen is, let's say if you had an assignment also, only the value of this one will be assigned and then the incrementation will happen. So if I had a print f after this one, it would have printed 6. You are correct. So post increment does not take, it does not get executed while this printf is running. My mistake.
Sir, in this case, how
Second
will
maybe
printf
same.
take value?
Sorry?
Sir, how the printing of values will happen by printf? Means how do we know that the printing will happen before incrementing or incrementing before printing?
No. So whenever you use post increment, the printing happen first, incrementation happen afterwards. If you use a pre-increment, right? Or actually, if you use a pre-increment, incrementation happens before printing. Okay, so that is the difference between pre and post operators.
So sir, here in the second option also it will print 5 only because it will increment afterwards.
Try it out. That's what I'm saying. So what I'm trying to say is, see, I'm not saying that. What I'm trying to say is I'm trying to give you an example of the confusions that you may have in your code. So whatever you are expecting out of your code, you need to really see how the code should be written, is what I'm trying to point you at, right? What the answer really is going to be, it will depend on how you write this expression. Whether you use post increment, pre-increment, star before, star after, parenthesis where you have done. So answer will be given based on what you write here. But what you need to be aware of, these the precedence of the operators when you use the pointer arithmetic is what I'm trying to point you at. Okay. All right. Structures and pointers, right? So we have another type of data type which we call user-defined data type in a way. We can create structures like complex numbers, right? So where you have two elements or two members in the structure, real and imaginary. And so to assign the value to each of the members, you use the dot operator, right? You use the dot operator with the structure, name where the memory is assigned, right? So we do structure complex number. So number is where the memory is assigned for the structure, and using that number variable, you can use dot operator and assign a particular value to the member, right? So this is one example where you can use the dot operator. Now the second example is where you have to use the arrow operator, which is where you have the pointer to the structure, right? So this is, let's say, the structure that we have defined, data structure, right? So data is the type of structure, and these are the two members in that. Now here in this function, we're not actually passing the variable directly, right? We are passing the address of that structure, right? So by using that pointer, right, star d here, structure data star d, this means that we are actually passing the pointer to this structure, right? The pointer to the structure, and therefore to access the member variables of the structure using a d variable, you have to use this arrow, right? When you use this arrow, then only you can access the member variable. But if you had no pointer here, right, if you just had a d, then you would use a dot operator, right? So this is how the members of the structure are accessed. We go to the functions, right? So in C, we obviously have functions, two types that you can generally see: library functions and user-defined functions. Okay, so the library functions we normally use, printf, scanf, string functions, file functions, and so on, right? Many other functions that you may have used, math functions. User-defined functions, you have to obviously have these three parts in, right? So first you have to define and call. These two are compulsory. Definition and function calling is compulsory. Declaration is used depending on the situation. And what do I mean by that? Yes, somebody has a question? Somebody has a question? Please try to not do unmute unless you have a question, right? So let's take this as an example, pass by value, pass by reference, where I'm showing you the scope of the variable example. But so let's say, here we have two functions, okay? We have pass by reference function and pass by value function. Now you can see that this is the definition of the function. So why it is called a definition of the function? It's called definition of the function because it also has the body, right? So the code of the function is given along with the header, right, or the function signature. That's why it is called a definition of the function, right? So these are the definition of the functions. Whereas if the function definition, right, comes after calling of the function. So in this case, you can see that pass by value is actually called here, but the definition of the function is done here. In that case, the compiler may not know that this function is available somewhere down below in the same file, or maybe in another file, another C file, another source files, right? So you have to basically say that this function is available and I'm going to provide you that. In order to do that, you have to do this. And this is basically called a function declaration, meaning that you don't have the body for the function, but you just provide the signature of the function saying that this function is available after the call somewhere in this file, or it is available in a separate file. Okay, so therefore there are three things that you have to worry about in the function definition, right? Now the scope of the variable, again, I think this you may have studied, but just to give an example, there are local and global variables, right? So global variables are generally defined above all the functions, which we have not used here. But then we have local variables, right? So local variables are the arguments that you are passing is also local variable, or anything that you declare within the function, right? So in the main function, we have declared this variable is also a local variable. This one is also a local variable, right? Because it is an argument that you are passing. Now, the arguments can be passed in two ways to the functions, right? One, passed by value, passed by reference. If you happen to give, a placement interview or exam for C, generally speaking, it is a very common question to be asked that what is the difference between passed by value and passed by reference? Okay. What is a passed by value? Passed by value means that you are passing only the value of the variable, right? So here we are saying that I, what does it mean? It is going to pass the value of 20 here, which will be then assigned to the variable A. But I is a local variable for a main function and A is a local variable for a pass by value function, which means that the addresses are different. Okay, the address for I variable is different, memory address for I variable is different, memory address for A variable is different. It's just that the value 20 is copied from the I variable address to the A variable address. That is why it is called pass by value. What does it mean? It means that if you change the value of A internally in this pass by value function, the original value of I will not be modified because those are two different variables. However, when I look at this other example of pass by reference, you can see what I'm doing here. We are not passing the value of I. We are passing the address of I. Okay, address of I. And that means that here I have to declare a pointer variable, right? Because this is not going to be a simple value. It is going to be the address of I, right? So therefore I have to declare a pointer variable of type integer because I is a variable of type integer. Now, internally to this function, if I change the value, right, where this A is pointing to, what am I saying? I'm saying that wherever A is pointing to, change the value of that variable to 10, which means that original variable I value will also change because I'm changing the value where A is pointing to, and A is pointing to the address where the value of I is stored. Okay, so this is basically the basic difference between the pass by value and pass by reference. Okay, and you will see that we are printing the value before calling the function, printing the value after calling the function in both cases. And you will see that here the value of I will not change, but here the value of I will be changed to 10. So pass by value, pass by reference. Okay. So these two are coming from the pass by value function, right? Function call. So you can see that original value of I was also 20, and after calling of the function also it was 20. Whereas in this case, the original value is 20 and the new value is changed to 10 because we changed that using the pointer variable. Okay, so this is basically an example of pass by reference. This is an example of pass by value. Okay. Now we look at pointer to array functions. Okay. Now this is sometimes very useful when you have multiple functions that you want to call, but those functions has to be called depending on a particular value or a particular index of an array, right? So let's say here we have these four functions, right? Add, sub, mul, division. And what we need to do is that depending on some option that is entered by a user, maybe 1, 2, 3, 4 options are entered by a user. Depending on that, you want to call a particular function. Now, of course, you can put a case, switch case statement also, and say that, okay, if the entered value is 1, then do this, entered value is 2, then do this. You can obviously do that. But there is also a better way that programming provides us, which allows us to define the array of function pointers. Okay, so all of these functions are also loaded into the memory, and they also have addresses. So what we can actually do is we can actually initialize the array, which is defined like this, right? So this is OPR is an array which has 4 elements, and that is a pointer array. So each of the element is not a simple value, but they are the pointer value, address values, right? And the function, because we are calling functions through this array, we are saying that all the functions will accept 2 arguments of integer type. So one condition obviously is that, or 2 condition obviously is that the signature of the function has to be the same, which means that the return data type has to be the same for all the functions, as well as the argument or parameters that you are passing to those functions has to be the same, right? Otherwise, you cannot use this particular format. Okay, and then each of these are the actual addresses that is coming from a memory where these functions are loaded. Okay, so once you execute the program, these functions will be coming into the memory, loaded into the memory, and that address will be assigned to each of these index values. Okay, and then you can call each of these functions by using this syntax. So I is basically nothing but an index to this array, right? And whatever the value of I that you provide will be passed as the will be used as the function value, right? So if I say OPR 0, then add function will be called. If I say OPR 1, then sub function will be called, and so on. Okay, so that is how your function call happens. So this is an example, right? So here I just provided 4 functions. Each of them do certain things, and depending on what input that you provide, it will be basically calling that particular function here. Okay, so this is what you can do with function pointers. Obviously, we have recursive functions also. I'm not sure if you have studied. Most likely, you may have studied. So there are recursive functions where the function signature or function is called by itself, right? So recursive functions are nothing but the functions that calls itself, right? So here we have a function called Fibo, which calculates the Fibonacci series, right? Which calculates the Fibonacci number. Sorry, you provide the argument. The same argument will same number of arguments and same data type argument will be provided each time when this Fibo function is called. So if the value entered is 0, then you return 0. If the value entered is 1, then you return 1. So these are the 2 base conditions that we have for the recursive function, right? These 2 are the base cases. And then you have a non-base case, which is over here, right? So you calculate the Fibonacci number using the recursive function call. You may have studied also the dynamic memory management. Did you guys study dynamic memory management in C programming course? Can anyone tell me? Yes. Okay.
Yes.
All right. Okay. So basically, we know that malloc is used for allocating the size in bytes, right? So we can say how many bytes we want to allocate, and the number of elements that you want to allocate, and the size of the each element that you provide. So basically, this is the number of bytes that you get. So here you are allocating 40 bytes of space, which means you are storing 10 integer values, right? And then malloc by default returns the void pointer because it doesn't know what kind of value you are going to, what kind of values you are going to store. So therefore, we actually have to do explicit typecasting, right? So using the typecasting, we can actually say that the return pointer that we have is going to be the integer pointer, not the void pointer. and that is what we are declaring, right? So basically, the way you can declare array is like this. Or if you don't know, if you have, if you don't know how many elements, right, here at the beginning, you can actually use the user defined value also. So you can actually ask user how many elements user wants to store in an array, and then you can use malloc to allocate the memory accordingly. Okay. Of course, we must do free, right? We must do free at the end of the program because malloc is something that is the memory is allocated by us in program. So the runtime environment doesn't know that this much space was allocated by us, right? Whereas if it is the memory allocation like this, so this is basically called a static memory allocation. So all these static memory allocations are, operating system is aware of them, and it will release these memory as soon as the program exits, right? The application exits. But since it doesn't know how much space using malloc we have allocated in our program, because that is why it is called dynamic memory allocation, operating system will not do anything about this one. We have to make sure as a programmer that we call a free function at the end of the program for all these malloc calls to release the memory back to the operating system. If you don't do that, eventually your computer will run out of memory, and the only way to recover from that is to reboot the system. Okay, so once you reboot the system, the memory will be freed automatically. But if you do free, for each of the malloc calls, then you don't have to worry about that, right? So similar example for the structures also. So this is for the primitive data type. You can do the same thing for the structures also. You can allocate the memory for structure variables as well, right? Or structure pointers as well. Some of the data structures, since you are familiar with the data structures, I'm going to run through it again fairly quickly because I want to make sure that we use the lecture time for the system software concept that we want to cover, right? Since you have an idea about these topics, I'll run through it. If you have any questions, you can stop me quickly. So array versus linked list. Right, so this is the array kind of data structure. Each of the element are addressed using a particular index values, right? Linked list is something like this, where each of the node, right? So we call each of these as a node value, and each of these nodes are dynamically allocated the memory, right? So it could be a single value, it could be a structure, whatever it can be, but each of these node is a single element, right? And element may have more than one value in form of structure. Okay, so you could have again a doubly linked list, a singly linked list, depending on how you have created it, right? So if you say single linked list, singly linked list, then you have a header or header pointer, and then each of the node will be pointing to the next node, right? So you only have the pointer in one direction, or the addresses in one direction. So you can always start from the head and go all the way up to the end. The last node will have the pointer pointing to a null, right? So null is basically the zero address or no address, which is what says that it is the end of the linked list, right? You could have a doubly linked list where you have the pointer in both directions, right? So you have the next pointers as well as you have the previous pointers, right? So the previous pointers, previous pointer for the head node will be null, and the next pointer for the last node or the tail node will be null, right? You can also keep a tail pointer here if you want, but no, then okay. You also have one more type of linked list, which is called a circular linked list, right? Now circular linked list also can be a singly or a doubly, right? So here you don't have a circular linked list, meaning that the last node has a null value in the pointer for the next pointer. Whereas in this case, the last node is again pointing to the head node. Okay, so that is why this is called a circular list, right? So circular linked list, basically never has a null pointer. It always points to some other node, except that if the head also doesn't have any node, meaning the linked list is empty, then the head value will be null. Otherwise, as soon as you add the first node, you always have the head is pointing to this node, and then the next of this node will be pointing to the same node, right? So again, the circular linked list will always have the pointer available, right? So same thing, circular linked list here, doubly circular linked list here. As I said, the next of the doubly linked list will be pointing to the head node, and then the previous of the head node will be pointing to the tail node. Okay, so again, you can do this. The other data structures that we may use through the course is a stack, right? So what is a stack? Stack obviously has two operations. We push the data into the stack and then we pop, right? So when you push it, it always goes at the top, right? So you have pushed 1, then you want to push 2, which goes here, then you push 3, which goes here, and so on. But then when you pop, you always have to get the top one, right? So basically that is why it is called LIFO, right? Last in, first out. So last in, first out means that last number that went in, that is the first number that will be coming out, right? So that's why stack data structure is called a LIFO data structure. Now stack data structure you can form using an array, or you can form using a linked list also. So both kind of implementations are available, right? So basic data structure, generally speaking, in all the systems that are used are arrays and linked list, right? Arrays and linked list. Now arrays and linked list, each of the value or each of the node can be a structure, right? Can be structure. So you can have multiple values in each node, but however, the data structure itself is basically either array or either or linked list. So stack is also the application of linked list or array, right? So stack can be formed using either one of the data structure. Similarly, you can form the queue, right? Queue has two operations, which we normally call NQ and DQ. NQ means that putting the data into the queue, and DQ means removing the data from the queue, right? So queue is a FIFO structure, first in, first out. So whichever value that went into the queue first, that will be the value that will be coming out also, right? First. So that's why it is called a queue structure, right? So you have the front, you have the back, and values go in from the back, and then from the front side you DQ the values. Okay. Some of the tree data structures that are used in creating system software, binary trees most likely use B tree. There are some flavors of B trees, general trees, midway tree, spanning tree, space partitioning tree, and some others, right? Decision tree, min max tree. So there are other now obviously we are not going to use all of these data structures, but I just wanted to make you aware that there are many data structures, and some of which we will be using. So in system software, most likely what we will be using is B plus tree. Okay, so B plus from the tree part, right? From the tree part, we'll be using B plus tree in the system software. Okay, all right. Now I do have couple of programs I've sort of like given just for the understanding point of view, right? So here, let's say we have this data structure, and that data structure defines the user, right? It's a doubly linked list data structure because, as you can see, I have the previous pointer and also the next pointer, and then I have head and tail, right? Using that data structure, I've shown the code how to add a new element into the new node into the list, right? So if we want to add a new node into the linked list, how do we do that? So we first allocate the memory, right? We assign the values that we want for the members of the structure, and then we have to do the pointer arithmetic using this particular code. So you can take a look at this code. If it is unclear to you, we can definitely discuss that in the Wednesday's lecture. This is the code for deletion of the node from the circular linked list. Okay, so again, the code is given to you. So just have a look at this code, right? Just so you understand how does it work. One thing I think I may have missed earlier is how the header files are used. Okay, so we jumped through this one, I guess, and I forgot to discuss the header files. Why it is important? It is important because we do use a lot of header files in our programming, right? In systems programming. And some of these header files have a lot of functions that we use. Okay, and these are these lists that I've given here are the header files that are available in our operating system. So these are the header files provided to us by the operating systems. Okay, and each of the header files has certain functions and global variables that are declared in these header files. Okay, so therefore it is important for us to know how the header files work. So let me do one thing. Let me go back to that example and show you how we can create our own header file and how do we use our own header file. Okay, so let's say, for example, we have a file called file1.main.c, right? File_main.c, which is where I've declared a main function. Okay, now I have a variable here. Okay, and then what we are trying to do is that we have another function, right, where we also use this variable. Okay, so what we want to do is that, first of all, why do we use the header file? So I said earlier that we whenever we use the functions, right, we have to do the function declaration if that function is not defined in this file or it is defined after the function call. Okay, after the function call. So in this particular case, what we have done is, if you look at this F1 function, this F1 function is actually in a separate file. Okay, which is this one. It's called file2other.c. Right, so file2_other.c is where this function is defined. Okay, but I'm calling this function from this particular file. So which means that when I'm calling this function, compiler doesn't know where this function is. And therefore, I have to give a forward declaration of the function. Forward declaration of the function. So what I can do is, let me first comment this header file thing out, and let me uncomment this one out. Okay, so extern keyword is optional for GCC. What earlier in the older versions of the compiler, what was happening is that there was a difference between the extern and the non-extern functions. If you write extern, it will assume that this function is defined in a separate file. But if you don't write extern, it will assume that this function is defined in the same file, but maybe after the call is made. Okay, that was the distinction. But now that, GCC doesn't care. I mean, if you write the extern or not, it's able to figure out whether the function definition is here or outside. It doesn't matter. But anyway, we have written extern here with the function name, right, with the function signature. And so what this is doing, it is telling me that when I'm calling this function, it is available somewhere. Okay, and that function is available somewhere, which is over here. And so this particular code will have to be used at the time of compilation, or actually at the time of linking, which I will show you when we go to the next chapter. So the linking is the step of the GCC compiler, which takes care of these things. So what do I need to do? In order to compile this code, I have to basically so I basically say GCC And then I can say file1 main.c, and then file2 other.c, right? Now, since my main function is in file1 main, right? The executable file will basically contain starting from this function. Okay, starting from this function. I can give any name to my output file, but I generally tend to give the same name as the source file where the main function is. Okay, so I'm going to give file1 main.out. So now you can see what I have to do. I have to say that this file, right? This file is my main file, but this file has some functions or some variables which are being used from this file also. So therefore, I also have to provide this other C file for compilation. And then using both the C file, the GCC compiler will actually give me a final executable output. Right? So you see that it didn't give any error. It didn't give any error, right? And I'll be able to then run file1 dot main. Sorry. Okay. So I'm able to run this, calling external function to global 20, and I'll explain what this output message is. So basically what we did, we assigned the value to 20, and then we are saying calling the external function to global, right, from the main one, which means that before calling the function, we are printing the value, which is what we are getting over here, which is what we are getting over there, right? Now this message is coming from the internal function from the separate file. So which means that now I'm calling my function f1, which is then going over here. Now this is the message that is coming from function f1, and you can see that the value of true global variable is changed to 15. Okay, and then that is what is printing over here, right? So that is coming as an output, right? Now, if you go back to the main, when we are printing the value here, this value also is changed from 20 to 15. Okay, this value also is changed from 20 to 15, because if you look at this variable here, this variable actually is not declared here. You can see that this variable is actually not declared here. I didn't say int true global. I just said true global. So that variable actually is declared here. Okay, this variable is declared here. So this variable is declared here, and then the main function is actually changing the value from that 10 to 20. And then inside this function, we are changing again the value from 20 to 15. So when we go back to the main function, the value of this variable is now 15 instead of 20. Okay, so we are kind of saying that we are using the global variable in both files. And as you can see, for the global variables, I did not even have to do this external. But generally speaking, it would be good to do the forward declaration of the variables also. Okay, so now what happens is that these forward declaration of the variables and the functions either can be directly done like this, but if there are many global variables, many functions that you want to do the forward declaration for, the better way is to put this code into the header file. And that is what we have done. So what we will do is that we will comment this out again, and we will uncomment this out again, and this is my header file. And if you look at this header file, it basically has these two lines. Okay, so we have the variable which basically we are saying that this variable is going to be used as the global variable for all the C programs, which will include this header file. Okay, and also we have the forward declaration of the functions. This is how you can actually use the functions and the variables across, or by sharing to the multiple C programs. And that is what we are doing here. Okay, so that is why I actually called it as true global. True global means it is not global to a file, but it is global to, or it is not a global to all the functions in the same file, but it is global to all the files, multiple C files also. Okay, and that is what I said we want to do. That's why I called it as true global. And so now using this header file, because we have included that header file here, right? Because we have included that header file here. So this variable is also declared here, and this function is also defined here, right? So the declaration of the variable and declaration of the function is done here, and therefore this header file will include both of them, and therefore I will not have to do these separately. I can just include this header file in all the C program where I want to include, these two things, and I will get it. So what we tend to do, or what operating system also suggests we do, is that we write C files which has all kind of library functions, or the functions that we repeatedly want to use, make the C files of those. Okay, and then you give the header file for those functions which are in those C files. Okay, and that header file has to be included in any code where they want to use this particular functions. This is the reason we include stdio.h, math.h, string.h, and so on. Because when you look at those files is nothing but the the declaration of those variables and the functions. And if I can find one, let me okay. So there's a locate command that you can use to search for a particular file. It will give you all the locations where that file exists. And you can see that there are multiple locations where that file exists. Let's look at this particular version. User include stdio.h. So I'm going to open gedit. And then I'm going to open that file. Actually, I need to go back. Other locations. Host files. No, sorry. Other locations. Computer user. User include, and there should be stdio.h here. stdio.h. Okay, so this is the file that we are going to open. When you look at this file, you see that there are some constants defined. There are some, you can see there are some extern with the file, with the function name defined. And if you look at some of the functions that we use, for example, printf. So you can see that, there is a printf function defined over here, or rather declared over here, not defined, right? This is not a definition, it's a declaration, forward declaration. So basically this is the forward declaration of that printf function. And that is why when we want to use a printf function, we have to include stdio.h. Okay. Similarly, if you go to, let's say, scanf, sorry, scanf, right? So scanf is also declared here. So basically what I'm trying to say is that you have these header files that are provided to us by the operating system, and each of these header files has some global variables or structures or these forward declaration of the functions. This is the reason we need to include those header files in our code like this. Now, generally speaking, we use the angle brackets like this, right? So less than sign, greater than sign, to represent that the header file is coming from a standard library or an operating system. Okay. Generally speaking, when we use the user-defined header file, meaning that the header file that we have created, we tend to use the quotation marks around it. Both the syntax will work for both the type of header files. So it is not going to complain. It is just the matter of understanding for the other programmers. So if you use the angle bracket, generally it is understood that this header file is coming from the operating system or standard library. Whereas when you use the double quotation marks around the header file, it is understood that these header files are written by us, by user, okay, general user. And they are not like system header files, okay? So this is what we can do with the header files. So that is what I wanted to point out. And you can see there are many header files, right? Many header files that are provided to us. In fact, if you do, ls-ltr /user include, and you will see that there are many header files here. Okay, so some of these files that you may be knowing, and some of these files we'll be using. Okay, many of these files we'll be using, like for example, stdiode.h we'll use signal.h, we'll use a wait. There was a wait one that I just recently saw. Wait, all of these header files we'll be using in our course. Okay, so I'll cover more in detail about the header files once we go through the content. As we go through the content, you will know which header file contains what information. But the ones which are highlighted in red in this slides, they are the ones which we are planning to use. Right? They will be used in our course. So these are some of the net header files. Net is used for the internet stuff. Right? So whenever we write socket programming, these are the files that we will be using, and so on. Right? There's some exercise that I've given you. Again, this will you can try it out. We'll put it in the quiz so that you can solve that. So that is where this chapter ends. Any questions so far?
Sir?
Yeah.
Sir, you said that the angular brackets represent that these are the header files is from the standard library, right?
Yeah.
Sir, what does the represent mean over there?
What is it?
What does represent mean over there?
What I mean to say is that when you use the angle bracket, right? So for example, let's say you have created a code, right? You write some C files and you give it to your friend. So when your friend looks at the file, he will see these kind of header files and he will also see this kind of header files, right? So that person can see the header files from both the areas, the ones that you may have created in your code and one that is used, that is created by the operating system developers or the standard library, right? What I'm trying to say is that if you give your source file, how does that person identifies that which header files are yours and which header files are not yours? Meaning that they are coming or they are provided to us by the operating system developers. That is why, to make that distinction, to make that identification, that when you use the angle brackets like this, it means that this header file is what you are using that has come from the operating system developers or is part of operating system or some sort of a major library. Whereas when you use this double quote, it means that this header file is something that you have created as part of your code. So to make that identification, right? So a person has to identify that this header file is yours and this header file is not yours. That's why we use these two different way of including the header files.
Yes, sir. And sir.
Yes, go ahead.
Sir, are the header files means what I want to ask is the standard library the same as the function provided by the operating system? What is the difference between the standard library and the functions that are provided by the operating systems?
What I'm saying is all the functions that are provided by operating system that we use in our code, there will have to be forward declaration done. All those forward declarations are done in some header file, and that is the list I have provided over here. These are the list of header files that you would have in your Ubuntu.
Sir, I'm not asking that. I'm not asking that, sir. What I meant to ask, sir, what I am asking is, you said that when we include the header files using angle brackets, it means that it is provided from the standard library or from the operating system.
Right.
So is the standard library provide? So what is the sir? Means what I meant to ask is will it be provided by standard library?
I understood your question. I think you don't know what the standard library is. So let me answer that question when we cover standard library function. Right? So see, because right now I think you are not able to make a distinction between the operating system and the standard library, right? That is what the problem is.
Yes, sir.
Right. So because you don't know what the standard library is, I won't be able to explain to you right now. So when we cover the library functions in GCC compilation steps, I will explain to you what that means. Then you will understand better, because then you know what the library functions are and what is the standard library functions are.
Okay, sir.
Yeah.
Okay, sir.
Okay. Any other question? All right. Okay. So what I'll do is, since we still have about 5 minutes, I will just start with the next chapter. Obviously, you will not go through it a lot, but I just want to give you a basic idea about what we are planning to cover or what we will be covering. Right. So the next chapter is what we are going to look at, how the GCC compiler works. What is so important about GCC compiler? Why do we use GCC compiler, and what are the different phases that it does to take your C file, your source file, and go all the way up to the executable file? That is what we are going to cover in this chapter. Okay, and there are mainly 4 steps that it goes through: pre-processing, compilation, assembling, and linking. So these are the 4 steps that it has to perform in order to take your C source file and bring it to your executable file. Now, once you have the executable file, you run it on your terminal window, and that executable file will be loaded into the memory. And that is why I've also put here a word called loading. Loading means that you take an executable file. So basically, for example, when I'm running it, right, when I'm executing some file, let me go back here. So when I'm typing my executable file name, and then when I say run, right? So how does it run this code, right? It obviously has to take this executable file, first load it into the memory, and then tell the computer, tell the processor to go to that memory location and start executing the code. That is what is called loading. Okay. Now, there are also 2 types of loading: dynamic loading and static loading, which we'll again look at it when we look at the library files, because there are 2 types of library files: static and dynamic. Okay. So when you look at the the steps of the GCC compiler, and if you want to if you are interested in the extra documentation, additional documentation, this is the link that I have provided. This is the link where you will find the online documentation of GCC compiler. It is a GNU, which is general user license is provided to it, so anybody can use it as far as it is part of your operating system, right? It supports your operating system and your source files. So as I said, there are 4 steps that it has to follow. Okay. The first step is called pre-processing step. Okay, so basically what is the pre-processing step? In the pre-processing step, it takes your C files and header files, and what all the header files that you have inside your source files, inside your C files, it will expand that. Okay, it will expand that. So it will take all the global variable definitions, it will take all the function call definition, it will include that in your source. Okay, and that is what we call pre-processed files. Okay, so your C source files is a machine dependent file, machine independent file, because you can use the same source file in this machine as well as you can also compile the same source file in another machine. Okay, for example, if you have a computer with Intel based processor, you can take the C source file and compile it here. Similarly, you can take the C source file from here and take it to maybe a Raspberry Pi, okay, or some other hardware which has an ARM based processor, which will then compile to ARM based processors. Okay, so this is a machine independent file. Again, the pre-processed file is going to be the machine independent file. Okay, so this is just an expansion of the header file that it does over here. That is the step which is called pre-processing. So you take the C file, take all the header files which are included in the C file and expand those header files. That is the pre-processed file. Then it takes the pre-processed file and performs the second step. It's called compilation. What is the function of compilation? Compilation is where it actually then takes the C source files and converts it into an assembly language. Converts it into the assembly language for a given processor. So again, if your computer has an Intel processor, it will compile the code in the Intel assembly language, which we call it as x86. x86 is the code word given to the Intel and AMD based processors assembly code. If your computer is using ARM based processor, then the same pre-processed file will be compiled into the assembly code, which will be equivalent to the ARM processor's assembly code. So basically now here you become a machine dependent, meaning that the assembly file you cannot take from one machine and run it on another machine. That is what we are trying to say, right? Then we take the assembly file, the GCC takes the assembly file, then it runs something called as assembler. Assembler is again a program as part of the GCC compiler. Okay, so it runs the assembler, it converts the assembly code, assembly files into what we call object files. Assembly code can be opened in the normal editor window, but because these are also text files, it can be viewed. Okay, but object files are the binary files. So the assembly code is then converted into the binary files with the code of the processor, which the processor really understands, the binary code which the processor really understands. So once you assemble the code, then that code becomes the binary code, and that binary code is supposed to be executed on the processor. But then there is one additional step called linking. What is a linking step? The linking step is nothing but combining multiple object files, because what will happen is one C file will give you one .o file. So for example, in our example that we had here, we had file 1_main.c. That will give me file 1_main.o. Similarly, file 2_other.c will give me another O file called file 2_other.o. Now you have two object files, and both has certain functions and certain variables. How do you combine them? How do you link them together? That is the functionality of the linker. So linker is a program that accepts multiple object files and combines into a single executable file. So at the end of the linking step, you finally get an executable file. So to take your source file and convert it into the executable file, there are these 4 steps. And the details of each of these steps we will look at in the next lecture. Okay. I think somebody had questions. What should we submit in quiz 6? Separate SH file according to the question and assess for their output. Yeah, correct. Any questions?
Sir, so the quiz is different or the lab assignment?
Okay, so what I've done is we finished the shell scripting on Wednesday only, right? Sorry, Thursday only, right? So we didn't had enough time to finish the quiz before the lab, which is on Tuesday, right? So what I decided to do is that I was supposed to give you the quiz last week, but then I also had to be done with the lab. So instead of lab assignments, I've given you the quiz assignment. And during the lab time, you solve those quiz problems, right, for the shell scripting. And then the following week, which is the next week, we will again do the lab assignments for the shell scripting. So you get more practice with the shell scripting is what I'm trying to say.
Okay.
Any other question? All right. Thanks everyone for joining. And I'll talk to you guys on Thursday.
Thank you, sir.
By tomorrow we